Yeah, good day to all. Myself, I am Dr. M. Gomadinayagam. I am working as an associate professor in the Department of Computer Science and Engineering, Ramco Institute of Technology. In this video lecture, I am going to discuss about switching concept in computer networks. I referred and used the PPT of data communication and networking, 5th edition of Ferozan. So I am going to start from what is network. Actually, we all know network is a set of connected devices. Suppose if we want to connect multiple devices, we have the problem of how to connect them to make one-to-one communication possible. One of the solution is to make a point-to-point connection between each pair of devices. But if we go for using a point-to-point connection between each pair of devices, we can't able to connect not more than two devices. Suppose if I want to connect more than two devices, a better solution for connection is by providing a switching concept. So what is switches? Switches are the devices. It can capable of creating a temporary connection between two or more devices linked to the switch. See the diagram here, letters A, B, C, D and J, that indicates the N devices which all are connected with each other with the help of the switching devices, which are represented as yellow color rectangle, which are labeled as Roman letter 1, 2, 3, 4, 5. So all the A to J devices are connected by 5 switches. It creates some temporary connection between each devices. When we talk about the switching, there are 3 methods of switchings are there. One is the circuit switch networks, another one is the packet switch networks, and last one is the message switch networks. Again, this packet switch network is classified into 2 types. One is the datagram networks and another one is the virtual circuit networks. Let me see one by one. Before we are going to talk about this each switching concepts, first we should know the switching and TCP/IP layers. When we talk about the switching at physical layer, that is called the circuit switching here, and it allows the signal to travel in one path or another. And when we talk about the switching at data link layer, it is a packet switching. It is normally done using virtual circuit approach. Switch at the network layer. At the network layer, we can have the packet switching. In this case, either virtual circuit approach or datagram approach can be used here. And when we talk about the switching at the application layer, we can have the message switching. The communication at the application layer occurs by exchanging the messages. Right. So now we are going to talk about the circuit switch networks. Generally, the circuit switch network is made up of set of switches connected by some physical links. So we have the set of switches here, switch number 1, 2, 3 and 4, which all are connected by some physical link. Here, in which each link is divided into number of channels, n number of channels, by using some multiplexing techniques like either frequency division multiplexing or time division multiplexing. So in the circuit switch network, suppose an N system A, it needs to communicate to the N system M. The system A needs to request a connection to the M. That request is accepted by all the switches between the source node A and destination node M, and also by M itself. This process is here called as the connection setup phase or connection establishment phase. Once the connection has established in the circuit switch network, then the source can send the message from A to destination M. So this phase is here called as the data transfer phase. Once all the data have been transferred, then this A is going to initiate the connection termination to the M. Afterwards, the M is going to release the connection. Then the resources are going to become free. That phase is here called as the connection tear down phase in the circuit switch networks. So we need to emphasize several points here related to the circuit switching. So generally the circuit switching takes place at the physical layer. Before starting the communication, the station must make a reservation for the resources to be used during the communication. So the data transferred between the two stations are here not packetized. So there is no addressing involved during the data transfer here. So one of the important note here is in the circuit switching, the resources need to be reserved during the setup phase. The resources remain dedicated for the entire duration of the data transfer until the tear down phases. And when we look at the efficiency of the circuit switch network, it can be argued that circuit switch networks are not as efficient as other two types of networks because the resources allocated during the entire duration of the connection, which are unavailable to other connections unless otherwise that is going to be released by the particular communication. Otherwise that resources are not used by any other connection. That's the reason this one is not efficient. And when we look at the delay, total delay in the circuit switch network is calculated based on the time needed to create the connection, transfer the data, and disconnect the circuit. See the diagram here. Suppose A wants to make a communication to the B. First, it should establish the connectivity between A and B. So, in order to establish the connection, it requires some time. So, connection establishment time. And once the connection has established, then A is going to transfer the data. It requires some time to transfer the data from A to B. That is the transfer data time. And once the data transfer is over, then A is going to initiate the connection disconnect request to the B. Afterwards, the B is going to confirm that request, that is disconnection request, that is confirmation about the disconnection. That is also going to be taken some time. That is here called as the disconnect the circuit time. So the whole total delay is going to be calculated in the circuit switches due to the time needed to create the connection, transfer the data, and disconnect the circuits. And let me talk about the packet switching. In packet switching, there is no resource allocation for the packet. So here the resources are allocated on demand basis. Allocation is done on first come first serve basis. When a switch receives a packet, no matter where it comes and where it goes, the packet must wait if there are other packets are going to be being processed by the switch. So there are two types of packet switch networks are there. One is the datagram networks and another one is the virtual circuit networks. Let me see one by one. First, we are going to talk about the datagram networks. Here it is sometimes referred to as the connectionless network. Why we have to say it is a connectionless? It does not keep the information about the connection state, and also it does not have any connection setup or tear down phases. So here each packet is treated the same by a switch regardless of its source or destination. See the diagram here, A and X, A is the source and X is the destination here. The A wants to transfer the 4 different packets to the X. Here all the packets 1, 2 labeled as 1, 2, 3, 4 from the A, it does not follow the same path to reach the destination. For example, packet 1 and 3 follow this path to reach the destination, and packet number 2 it is follow this path and to reach the destination, and packet number 4 it is going to be follow this path to reach the destination. So all the packets not follow the same path to reach the destination. That is the reason it can't be able to keep the information about the connection state. That's the reason we can say it is a connectionless networks. So here we have a very big question. If there is no connection setup and disconnect phases are there, how the packets are going to be routed to their destination in a datagram network. So in order to do that, it uses the routing table in the switches based on the destination address. Generally the routing tables in the switches are dynamic one, and these all are going to be updated in a periodic manner. So what is the destination address and corresponding forwarding ports? Based on the destination address and corresponding forwarding port output ports only, your packets are going to be forwarded, and that informations are recorded in the tables, routing tables. See, this diagram shows the routing table of this particular switch. This switch is having a 4 interfaces labeled as 1, 2, 3, 4, right? So suppose particular system is connected, destination address of the system 1, 2, 3, 2 is connected in this interface 1 means, right? So this routing table is going to be built at as destination address is 1, 2, 3, 2 and connected port is 1. Suppose a packet which is received from some other system to this switches, it is going with the destination address is 1, 2, 3, 2. Immediately that packet is forwarded to the output port number 1. Right. So what is this destination address? Every packet in the datagram networks, it carries some header information. That header information contains some destination address of the packet. So when the switch receives the packet, this destination address is going to be examined first. Then it is going to be consulted with the routing table in order to find the corresponding output port through which the packet should be forwarded. So here some 2 points we had been noted in the datagram networks. A switch in the datagram network uses the routing table that is based on the destination address. Generally, the destination address in the header of a packet in Datagram network remains the same during the entire journey of the packet. So destination address is not going to be changed during the transmission of your packet. So the destination address is always same from the beginning to end of the destination. So when we look at the efficiency of the Datagram network, it is better than that of the circuit switch network because the resources are allocated only when there are packets to be transferred. If the source sends a packet and there is a delay of few minutes before another packet can be sent, means the resources can be reallocated during these minutes for the other packet from the other sources. So when we look at the delay, although there are no setup and tear down phases, each packet may experience a wait at switch before it is going to be forwarded. See the diagram here. Suppose A wants to transmit the data to B, right? This packet is going to be forwarded through the two intermediate switches here, switch 1 and switch 2. Each and every switches, it is going to be look at the routing table. Afterwards, it is going to be find out the corresponding output port. Then only it can be able to forward it. So some amount of time, the packet is going to be waiting this particular switches. Similarly, the next switch and finally it is going to be reached. That time is here called as the waiting time. Otherwise, we can say experience at the wait at switch before it is going to be forwarded. In addition to that, since not packeting the message necessarily travel through the same switches, the delay is not uniform here. And let me talk about the virtual circuit switching. The key idea behind the virtual circuit system is virtual circuit switching is, first we have to set up the virtual connection from source host to destination host. Then we have to send the data. So there are two-stage processes that in a virtual circuit switching. One is the connection setup, another one is the data transfer. So when we look at the connection setup, it is going to be established the connection state in each of the switches between the source and destination host. So the connection state for single connection consists of entry in the virtual circuit table. Simply we can say it is the VC table in each switch through which the entire connection passes from source to destination. And what's the information contains in the VC table? Generally, the VC table contains a virtual circuit identifier, an incoming interface, an outgoing interface, and potentially different VCA number is also having that. So if a packet arrives on the designated incoming interface and that a packet contains the designated VCA value in its header, means then the packet should be sent out to the specified outgoing interface with specified outgoing VCA value, first having placed in the header of the packets. So there are two broad classes of approach to establishing the connection state. One is the network administrator will configure the state. That type of virtual circuit is here called as the permanent virtual circuit. So here the network administrator can delete or modify the permanent virtual circuit and can be thought of as a long-lived or administratively configured virtual circuit. And another way to establishing the connection status, a host can send message into network to cause the state to establish. So this is referred as a signaling, and the resulting virtual circuit is here called as the switched virtual circuit. Here, host may set up and delete such virtual circuit permanent dynamically without the involvement of any network administrator. Let us assume that network administrator, they want to manually create a new virtual connection between this diagram host A to host B, right? Actually, this connection is established through switch 1, switch 2 and switch 3. Suppose host A wants to send the data, means the data is forwarded through switch 1, switch 2, switch 3. Finally, it is going to be reach the host B. Unless otherwise, the network administrator knows the connectivity which are established through the switch 1, switch 2, switch 3, they can't able to create the permanent virtual circuit here. So prior they are going to create the permanent virtual circuit, a network administrator should have a knowledge about how the host is connected through what are the switches. Then only they can able to create a permanent virtual circuits. Right. So then the administrator can then picks a VCA value that is currently unused on the each link for the connection. For our example purpose, we are going to be taken, suppose a VCA value 5 is chosen for the link from host A to switch 1. So the 11 is chosen from link from switch 1 to switch 2. So the switch 1 will have the entry in the VC table as shown below here. So the switch 1, actually the host A is connected to the interface of 2. The VCA value for this connection is, they have referred as the 5. Okay, then it is going to be forwarded to this port number 1 So interface number 1. So the incoming interface is 2, incoming VCA value was 5, and outgoing interface is 1, and outgoing VCA value was 11. That is the way VCA value and outgoing interface and incoming VCA and incoming interfaces are noted down in the virtual circuit table of each and every switches. And similarly, suppose we have to assume that VCA of 7 is chosen to identify the connection between switch 2 to switch 3, and VCA of 4 is chosen for link from switch 3 to host B. Then the VC table, virtual circuit table of switches 2 and 3 are shown below here. So the first table shows the VC table of the switch 2, where the incoming interface is 3, incoming VCA is 1 1, and outgoing interface is 2, outgoing VCA value is 7. And similarly, the VC table for the switch number 3 is incoming interface is 0, incoming VCA value is 7, outgoing interface is 1, and outgoing virtual circuit interface identifier value is 4. Okay, so for any packet that A wants to send to B, first A puts the VCA value 5 in the header of the packet first. Then it sends it to the switch number 1. Switch 1 receive any such packet through this interface 2 and uses the combination of interface and VCA value as 1 1. That is the VCA value of this interface, and which is going to be stored in the packet. Then the table entry on switch 1 tells that switch to forward the packet out of the interface 1 and put the VCA value as 1 in the header, that is 11 in the header. Then next, the packet will arrive at the switch 2 once this packet has received to the switch 2. Switch 2 lookups the interface 3 and VCA value 1. VCA value 1 1 and its VC table. So, and it is going to send the packet to the port number 3 here. Okay, after updating the VCA value appropriately, this process is going to be continue again and again to reach the destination. So to host B, this identifies that once it receives the VCA value of 4, and based on that VCA value, this host B is going to be identifies that the packet has coming from this host A. Right, now to complete the connection, everyone needs to be told what their downstream neighbor is using the VCA for this connection. So for that, host B sends the acknowledgement of connection setup to switch 3, and it includes in that message the VCA value that it chooses, 4 and so on. Finally, it switches 1 passes the acknowledgement on to the host A, telling it use the VCA value as 5 for this particular connection. So to transfer the data, that is to transfer a frame from source to its destination, all the switches need to have table entry for this virtual circuit. So in order to do that, the virtual table contains the 4 columns. It means that switch holds 4 pieces of information for each virtual circuit that is already set up. That is 4 information in the sense, see the backslide: incoming interface, incoming VCA value, outgoing interface, and outgoing VCA value. So each packet should have these 4 piece of information as shown in the 4 columns of the VCA table. Right. So now we come to the connection termination phase. In this phase, source A, after sending all the frames to the B, it is going to send the special frame called the teardown request to the destination B. Then the destination B responds with the teardown confirmation frame. Once the confirmation frame is going to be received by all the switches in between the destination to source, all the switches are going to be delete the corresponding entry from the tables. So the corresponding entry of the table is going to be empty now once the connection is going to be disconnected. And when we look at the efficiency, the resource reservation in the virtual circuit network can be made during the setup or can be on demand during the data transfer phase. In the first case of that, the delay for each packet is same, but in the on-demand base, that is in the second case, each packet may encounter the different delay from source to destination. So here there is one big advantage in the virtual circuit network. Even if the resource allocation is on demand, the resource can check the availability of the resource without actually reserving it. And one point we had been noted regarding to the virtual circuit switching. In the virtual circuit switching, all the packets belonging to the same source and destination travel the same path. It does not follow the different path similar to the your datagram network. Here all the packet has to follow the same path to reach the destination, but the packet may be arrive at the destination with different delay, suppose if you are going to use the resource allocation as in the on-demand basis. Right, when we look at the delay in virtual circuit network, there is one time delay for setup, connection setup, and one time delay for tear down. If the resources are allocated during the setup phase, there is no wait time for individual packets. So thank you. We will see in the next video lecture.